Let's explore PHP security, focusing on cross-site scripting, or XSS prevention techniques. This presentation will cover what XSS is, the different types of XSS attacks, and how to protect your PHP applications against them. We'll delve into practical examples and best practices to ensure your web applications are secure. What exactly is cross-site scripting? XSS is a type of security vulnerability that allows attackers to inject malicious scripts, such as JavaScript, into web pages. When other users view these compromised pages, the injected scripts can execute, potentially stealing sensitive data like login credentials, hijacking user sessions, or defacing the website. It is crucial to understand how XSS works to effectively prevent it. There are mainly three types of cross-site scripting attacks. First, reflected XSS. The script is injected via URL parameters or form submissions and is immediately reflected back to the user. Second, stored XSS. The malicious script is stored in the website's database, message forms, visitor logs, comment fields, etc., and executed when other users load the affected page. Third, DOM-based XSS. The attack manipulates the document object model in the victim's browser, with the malicious script not being sent to the server at all. Let's look at a vulnerable code example. Here's a snippet of PHP code that's susceptible to XSS. The code retrieves a username from the URL parameter name, using the getRequest method, and directly outputs it without any sanitization. An attacker could input a script tag containing malicious JavaScript, which would then be executed in the user's browser. This is a dangerous practice as it allows arbitrary code execution. Now let's look at a secure PHP code. The key here is to use the htmlspecialchars function. This function escapes HTML special characters, converting characters like less than, greater than, ampersand, and quotes into their corresponding HTML entities. By applying htmlspecialchars to the username variable before outputting it, we prevent the browser from interpreting any HTML or JavaScript code, thus mitigating the risk of XSS. The ent_quotes flag handles both single and double quotes, and specifying the character encoding like UTF-8 ensures proper encoding. Another crucial aspect of XSS prevention is input validation and filtering. Here's an example using PHP's filter functions. The filter input function allows you to validate and sanitize input from various sources such as POST or GET requests. In this example, we're validating an email address using the filter_validate_email filter and sanitizing a name input using filter_sanitize_string. If the email is invalid, the script will stop to prevent further processing of malicious data. This helps ensure that only valid and safe data is processed by your application. Content Security Policy, or CSP, is a security feature that allows you to control the sources from which the browser is allowed to load resources. By defining a CSP, you can prevent the execution of unauthorized scripts, reducing the risk of XSS attacks. The code shows how to set a CSP header in PHP. The script source self directive allows scripts only from the same origin, and the object source none directive disables the use of plugins. This provides an additional layer of security by restricting the resources that can be loaded and executed by the browser. To summarize the best practices for XSS prevention, always escape output. Use htmlspecialchars for all user data displayed in HTML context. This ensures that any potentially malicious code is rendered as text, preventing it from being executed. And validate input. Implement proper input validation and filtering on the server side to ensure that only valid and safe data is processed by your application. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.